Hi, hello, how are you all of you? Good morning to all of you. Myself Sudhakar Reddy, I am a faculty in mathematics. Welcome to my channel Maths for All. Okay, from today onwards, I am going to deal with the topics JEE and advanced. Okay, so in that, the very important topic in the geometry, that is straight line. So we are going to discuss about straight lines first. I don't want to waste your time unnecessarily. So the very first chapter in the coordinate geometry, that is straight lines. So very important topic in JEE and advanced. JEE mains as well as advanced. It's very important topic. It's the basics of geometry. It's the basic thing of geometry, straight lines. So to discuss about the straight lines, first of all, you should know about inclination. Inclination. This is the very first topic in the straight line. Inclination. So let us discuss about the definition of inclination. So what is inclination? If a line L is equals to 0, if a line L is equals to 0 makes an angle theta with the positive direction of x-axis. It's very important. The positive direction of x-axis, that is anti-clockwise direction. Positive direction is same as anti-clockwise direction. So if a line L is equals to 0 makes an angle theta with the positive direction of x-axis, then theta is called inclination. Simply, inclination is nothing but angle. Remember, every angle should not be inclination, but every inclination is an angle. So inclination is nothing but angle. But for this angle, there is a speciality. What is that? So that angle is the angle made by the line with the positive direction of x-axis. Very important. Positive direction of x-axis. Positive direction means anti-clockwise direction. Positive direction means anti-clockwise direction or counter-clockwise direction. Remember, so this is about inclination, right? After the inclination, the second concept, the straight line after the inclination is slope of a straight line. What is that? Slope of a straight line. Just now I have discussed about the concept of inclination. What is the inclination? See, this is x-axis and this is y-axis. So a line L is equals to 0 may be like this. This is the line L equals to 0. Achha. So this line L equals to 0. Makes an angle. See this? Which direction it is? This is anti-clockwise direction, that is positive direction. So this is the angle made by this line L equals to 0 with the positive direction of x-axis. So this theta is called the inclination. Just now we discussed about that. So if theta is the inclination of a line, what is that? If theta is the inclination of a line, then the slope of this line L equals to 0 is denoted by m. Slope is usually denoted by the letter small m, and d is defined as tan theta. What is theta there? So very important thing, theta is the inclination. So if theta is the inclination of a straight line, then the slope of the line L equals to 0 is defined as tan theta, and d is denoted by m. So see here, m is equals to tan theta. Remember, the definitions have no proofs. Then man use cheskuntam. The definitions have no proofs. M is equals to, what is m? Slope. What is theta? Inclination. If theta is the inclination, then slope of that particular line is defined as tan theta. Right. So that is about slope of the straight line. You want to note it? Make it note. So now I'll ask a small question to you. Slope of x-axis. Slope of x-axis. Slope of x-axis. So just now discussed about the inclination and also the slope of a straight line. So now I want to find out the slope of x-axis. Of course, x-axis is a straight line. Right. So now for this, we should know about the inclination. Inclination of what? Inclination of what? X-axis. Is x-axis a straight line? Yes, why not? So can you please tell me, the line x-axis makes an angle 0 degrees with x-axis. X-axis to ఎంత angle చేస్తుంది? So the x-axis makes an angle 0 degrees with x-axis. That means the inclination of x-axis is 0 degrees. Why? Because this is x-axis. Now I am going to take the line x-axis again. So here the x-axis coincides with x-axis, right? So the inclination of x-axis is 0 degrees. Inclination of x-axis is 0 degrees. So therefore the slope of x-axis is tan 0 degrees. Here 0 degrees is nothing but inclination of x-axis. What is inclination of x-axis? 0 degrees. Then slope of x-axis is m is equal to tan 0 degrees. Tan 0 means 0. The slope of x-axis is 0. The slope of x-axis is 0. Now, slope of a line parallel to x-axis. Slope of a line parallel to x-axis. Slope of a line parallel to x-axis. Suppose if a straight line is like this. Suppose if a straight line is like this. Is it a line parallel to x-axis? Yes, it is a line parallel to x-axis. Now can you please tell me the line, tell me the angle made by this line with the positive direction of x-axis? What is the angle? What is the inclination of this straight line? Is there any angle? Is there any inclination? No, because this line is parallel to x-axis. That means this line makes an angle 0 degrees with x-axis. This line makes an angle 0 degrees with x-axis. Therefore, the inclination of this line is also 0 degrees. So the slope of this line is also 0. So the slope of x-axis is 0. The slope of a line parallel to x-axis is also m is equals to tan 0. That is equals to 0. So the slope of a line parallel to x-axis is 0. The slope of x-axis is also 0. Right? This is from definition. Now again, this is x-axis and this is y-axis. This is x-axis and this is y-axis. Now I want to know about slope of y-axis. I want to know about the slope of y-axis. So now this is x-axis and this is y-axis. Now this y-axis makes an angle 90 degrees. See, this is a positive direction. This entire angle is 90 degrees, right or not? So the y-axis makes an angle 90 degrees with the positive direction of x-axis. So what is the inclination of y-axis? The inclination of y-axis, theta is equals to 90 degrees. What is the inclination of y-axis? 90 degrees. So therefore slope of y-axis is m is equals to tan 90 degrees. So m is equals to not defined, so that is usually denoted by infinity. So the slope of y-axis is not defined. I think everybody knows, but some of you know why the slope of y-axis is infinity. Right? So this is the reason. This is the reason the slope of y-axis is infinity. Suppose a straight line is like this, which is parallel to y-axis. A straight line is like this, which is parallel to y-axis. So this line is also makes an angle 90 degrees with the positive direction of x-axis. So therefore, the slope of a line parallel to y-axis is also not defined. See, what is slope of x-axis? 0. What is the slope of a line parallel to x-axis? 0. What is slope of y-axis? Not defined. What is the slope of a line parallel to y-axis? Not defined. 4 things are very, very important. After that, slope of a straight line, joining 2 points, slope of a straight line joining 2 points, right? So as you know, I think so, if ax1 y1 and bx2 y2, if ax1 y1 and bx2 y2 are 2 points, in a plane, then the slope of the line joining 2 points, the slope of the line joining 2 points is, the slope of the line joining 2 points is y2 minus y1 by x2 minus x1, y2 minus y1 by x2 minus x1, or y1 minus y2 by x1 minus x2. I think so many people know the formula, but some people know the concept. But for JEE and JEE mains and JEE advanced, the concept is very, very important, but not the formulas, right? So try to learn the concept, but not the formulas. Remember, very, very important. So let us discuss why the slope of line joining 2 points is y2 minus y1 by x2 minus x1. How do we apply the concept? How can we apply the concept? Let us see, right? Again, I am going to take x-axis and y-axis. So let us say this is the point A, x1 comma y1, and I am going to take the point B here, x2 comma y2. Right. Of course, this is horizon. Right now, listen. See here. I am going to draw a perpendicular from A to x-axis. Let us say this is M. Of course, this is horizon, right? So now, can you please tell me about OM? As this point is x1, y1, OM is x1, and of course AM is y1. Right. Again, draw a perpendicular from B to the x-axis, same again, and let us say this is N. And ON, this is nothing but x2, and BN is nothing but y2. But in this case, what we are going to deriving? So we are going to deriving the slope of the line segment joining the points ax1, y1 and bx2, y2. So join these 2 points. Extend this line segment to meet the x-axis in some point. Extend the line segment AB to meet the x-axis in some point. So let us say this is the theta, this is the angle made by this line AB with the positive direction of x-axis, right? So can I say this theta is inclination again? Yes, this is the inclination of this line, right? This is the inclination, theta is the inclination of this line AB. So now what is the slope of that line AB? From the definition, tan theta. The slope of the line segment AB is tan theta. Adin sir, tan theta ani cheppaledu maku y2 minus y1 ani chepparu kada. Yes, let us derive. So join a line like this parallel to x-axis. If this angle is theta, then this angle is also equals to theta. Why? Because these 2 lines are parallel. Achha. So now this ON distance is x2 and OM distance is x1. Nah? So now I want MN. So MN, this distance is x2 minus x1. This total distance is x2 and this is x1. So I want MN. MN is nothing but total minus small 1 x2 minus x1. In a similar way, let us name it as C. Right? What is BN? Total BN is y2, but CN. What is CN? We don't know. Achha. CN is this one. No? CN is nothing but AM. So AM x1. So CN is AM y1. CN is also y1. So now BN is y2 and CN is y1. I don't want both. I want BC. BC is nothing but y2 minus y1. So this BC is y2 minus y1. So for your convenience, I am going to separate this small diagram, small right angle triangle. I am going to separate from that. So this is A, and of course this is B, and of course this is C. And here the angle at A is theta, correct? The angle at A is theta. And what is side AC? x2 minus x1. And the side BC is y2 minus y1. Side BC is y2 minus y1. So now from this right angle triangle, can we calculate the trigonometric ratio tan theta? Yes, I can. Why? Because theta is the angle, and y2 minus y1 is opposite side of theta, and x2 minus x1 is adjacent side of theta. And from the trigonometric ratio tan theta formula, opposite side of theta by adjacent side of theta. So from this right angle triangle, tan theta is equals to y2 minus y1 by x2. Tan theta is equals to y2 minus y1 by x2 minus x1. But here, what is theta? Come again, what is theta? Theta is inclination. What is theta? Theta is inclination. See, if theta is inclination, then slope is m. So here m is nothing but y2 minus y1 by. Like this, we can derive the slope of a straight line joining 2 points in a plane. This is the formula, and this is the proof. The slope of a straight line joining 2 points is m is equal to y2 minus y1 by x2 minus x1. Like this, we can prove it. Right? Let's go for the next concept. So till now learned about inclination and the slope of line segment, slope of a straight line, and slope of x-axis, slope of y-axis, slope of a straight line parallel to x-axis, slope of a straight line parallel to y-axis, and slope of a straight line joining 2 points. Now the next concept is angle between two intersecting straight lines. Angle between two intersecting lines. Angle between two intersecting lines. This is a very important concept. Very important concept. See. Again, this is x-axis. This is y-axis. Angle between, right? What is that? Two intersecting lines. That means here we have to take two lines initially. So let us take the first line is like this. This is the line 1, that is L1 equals to 0. See, this line makes an angle theta 1 with the positive. Line 1 now. So this line makes an angle theta 1 with the, see, is it the positive direction? Yes, why not? This is the positive direction. So this line L1 equals to 0 makes an angle theta 1 with the positive direction of x-axis. So can I say it? Is it inclination? Yes, that is the inclination. So if theta 1 is the inclination of this line L1 equals to 0, then the slope of this line is tan theta 1. So that is denoted by m1 here. m1 is equals to tan theta 1. It is very clear that theta 1 is the inclination. If theta 1 is the inclination, slope is tan theta 1. Here that tan theta 1 is denoted by m1. What is m1? Slope of the first line. Right. Let us take the second line is like this. This may be the second line. That may be the second line. This is L2 equals to 0, right? That is L2 equals to 0. That is the second line. Right. So now the second line makes an angle theta 2. The second line makes an angle theta 2 with the positive direction of x-axis. Sir, can we take the angle like this, sir? No, we cannot take the angle in negative direction. If you take the angle in negative direction, that may not be the inclination. Right. So here the angle is in anti-clockwise direction. So this is the anti-clockwise direction. So that theta 2 is the inclination of the second line. If theta 2 is the inclination of the second line, then slope of the second line is tan theta 2 from the definition. So let us say that is m2. So m2 is equals to tan theta 2. m2 is equals to tan theta 2. Right? m1 is equals to tan theta 1. m2 is equals to tan theta 2. What are m1 m2? Come again. What are m1 m2? m1 and m2 are the slopes of the two intersecting lines. m1 is the slope of L1 equals to 0. m2 is the slope of L2 equals to 0. Now the two straight lines are intersecting at a particular point P, and now this is the angle. Now this is the angle between the two straight lines. Let us say theta. Let us say that is theta. What is theta? Theta is the inclination or not? No, here this theta is not the inclination. Very important point. Here this theta is not the inclination. Is it the angle made by the line with the positive direction of x-axis? No, no, no. This is theta. This theta is the angle between the two intersecting lines. That is not at all a inclination. Remember? Yes, it is angle between the two straight lines. Here observe, there will be a triangle here. There is a triangle. Huh? So in this triangle, theta 2 is the exterior angle, right? Theta 2 is the exterior angle, and theta 1 and theta 2 are the internal angles opposite to this external angle. Correct? Right. So in a triangle, there is a property. In a triangle, there is a property that external angle is equals to sum of two opposite internal angles, right? So here what is external angle? Theta 2 is equals to sum of two opposite internal angles, that is theta 1 plus theta. From this, theta is equals to theta 2 minus theta 1. Theta is equals to theta 2 minus theta 1. So apply tan on both sides. Tan theta is equals to tan of theta 2 minus theta 1. Tan of theta 2 minus theta 1. So I wrote the formula of tan of A minus B. Tan theta 2 minus tan theta 1 by 1 plus tan theta 2 into tan B. Isn't it? But initially we write tan theta 1 as m1 and tan theta 2 m2. Just replace the values of tan theta 2 and tan theta 1. So tan theta is equals to m2 minus m1 by 1 plus m1. Tan theta is equals to m2 minus m1 by 1 plus m1. In sometimes, if it is theta 2 and if it is theta 1, so here m1 and m2 may interchanges. M1 and m2 may interchanges. The formula for this is tan theta equal to m2 minus m1 by 1 plus m1 m2, or tan theta equal to m1 minus m2 by 1 plus m1 m2. That's why we have to write modulus there. So tan theta is equals to modulus of m1 minus m2 by 1 plus m1 m2. But that is not the reason to take the modulus. Sir, why you take the modulus symbol, sir? Let me explain. Up to here, noted. So this is the formula to find out the angle between the two straight lines when the slopes are given. What is that? What is the formula? Tan theta is equals to modulus of m1 minus m2 by 1 plus m1 m2. This is the formula to find out the angle between the two straight lines when the slopes are known. Make a note. So, what is the formula? If m1 comma m2 are the slopes of two intersecting straight lines and theta be the angle between them, then tan theta is equals to modulus of m1 minus m2 by 1 plus m1 m2. Tan theta is equals to modulus of m1 minus m2 by 1 plus m1 m2. Yeah, why we take the modulus symbol, sir? Let me explain clearly. That is very important concept. What is theta? What is theta? Here theta is the angle between two intersecting lines. Angle between two intersecting lines, right? Let us confirm one thing. How many angles are there between two intersecting lines? How many angles are there between two intersecting lines? Yes, so many people have said that, sir, there are 4 angles, sir. 1, sir. 2, sir. 3, sir. 4, sir. There are 4 angles, sir, between two intersecting lines, sir. 1, sir. 2, sir. 3, sir. 4, sir. I will take one more here, sir. 5, sir. 6, sir. 7, sir. 8, sir. Some are saying, sir, there are infinite angles between two straight lines, sir. Is it correct? No. Not at all. So there exist only 2 angles. There exist only 2 angles between two intersecting lines. There exist only 2 angles between two intersecting lines. Of course, if this angle is theta, if this angle is theta, then this angle is also equal to theta. Both these 2 angles are equal. So, and this is another angle. This is another angle. So that means there exist 2 angles between two intersecting side lines. If they are not perpendicular, then one angle is called acute angle, other angle is called obtuse angle. One angle is called acute angle, other angle is called obtuse angle. Unless he has mentioned angle between the two straight line means acute angle, how to take, that is mandatory. Unless he is mentioned what is the angle between two straight line means acute angle. Acute angle. Why we take like this, sir? There is no reason, sir. Suppose what is this? What is this? If somebody asks you what is this? 5. 5. Is it plus 5 or minus 5? Is it plus 5 or minus 5? Plus 5, sir. Where is plus? Where is plus here? No need to write, sir. Can I say this is minus 5? No, sir. Why? There is no minus, sir. There is no minus, sir. Without minus, how do you take minus 5, sir? Unless he is mentioned in a similar way, unless he is mentioned the angle between the two straight line means acute angle. Acute angle. Acute angle means always less than 90. Less than 90 means it lies in first quadrant. In first quadrant, tan theta positive. That's why we take the modulus symbol there. That is the reason behind it. Understood? So, what is the formula to find out the angle between two straight lines, two intersecting straight lines? Tan theta is equals to modulus of m1 minus m2 by 1 plus m1 m2. What are m1 m2? Yeah, their slopes. M1 m2 are the slopes of two straight lines. Right. So after this, there will be two important formulas based on this. Note number 1. Suppose if the two straight lines are parallel to each other. If the two straight lines are parallel to each other. The two straight lines are parallel to each other. Let us discuss what will happen now. So now this is the line L1 equals to 0 and this is the line L2 is equals to 0. L2 is equals to 0. Right? If the two straight lines are parallel, they never intersect. That means, is there any angle between the two parallel lines? No. Here in this case, what about theta? What about theta? Is there any angle between the two parallel lines? No. So here the angle between the two lines is 0 degrees. So tan theta, so theta equals to 0 degrees. Just replace this theta here. So tan 0 degrees is equals to modulus of m1 minus m2 by 1 plus m1 m2. Modulus of m1 minus m2 by 1 plus m1 m2. As you all know, the value of tan 0 is 0. So 0 is equals to modulus of m1 minus m2 by 1 plus m1 m2. So just apply the cross multiplication. Then what will happen from this? m1 minus m2 is equals to 0. So that m1 is equals to m2. It's very important condition. m1 is equals to m2. What are m1 and m2? m1 and m2 are the slopes. They are equal. m1 and m2 are the slopes. They are equal. That means slopes are equal. When the slopes are equal, the two straight lines are parallel to each other. The two straight lines are parallel to each other, then their slopes are, and vice versa. If the slopes are equal, then the two straight lines are parallel to each other. It is the vice versa condition. If the two straight lines are parallel, then the slopes are equal. If the slopes are equal, then the two straight lines are parallel to each other. This is the first case based on this point, this concept. Okay. Now the second point. If the two straight lines are perpendicular to each other, if the two straight lines are perpendicular to each other, if the two straight lines are perpendicular to each other, let us see what will happen. So let us say this is the line L1 equals to 0. This is L1 equals to 0. And now this is L2 equals to 0. Now these two lines are intersecting here, and angle at the point of intersection is 90 degrees here, because the two lines are perpendicular to each other. So here theta is equals to 90 degrees. Right? Here theta is equals to 90 degrees. Once again, I am going to replace this theta in the formula. So tan 90 degrees. So tan 90 degrees is equals to modulus of m1 minus m2 by 1 plus m1 m2. And as you all know, just now I said tan 90 is not defined. So not defined means you can write 1 by infinity. So infinity can be written as 1 by 0 or 2 by 0 or 3 by 0, whatever it may be. Something by 0 is called infinity. So I wrote 1 by 0. What m1 minus m2 by 1 plus m1 m2. Again, apply cross multiplication. So this 1 plus m1 m2 into 1, it is 1 plus m1 m2 is equals to 0. So therefore 1 plus m1 into m2 is equals to 0. From that, m1 into m2 is equals to m1 into m2 is equals to minus 1. m1 into m2 is equals to minus 1. Well, again, m1 and m2 are the slopes. Here I am going to multiply the slopes. So I am going to take the product of slopes. So here the product of slopes is equals to minus 1. What is the product of slopes here? Minus 1. So when the product of slopes is equal to minus 1, the two straight lines are perpendicular to each other, and vice versa. If m1 and 2 equal to minus 1, then the two straight lines are perpendicular to each other. If two straight lines are perpendicular to each other, then m1 and 2 equal to minus 1. Minus 1. These two are very, very important conditions. If the two straight lines are parallel, then the slopes are equal. If the slopes are equal, then the two lines are parallel to each other. The two straight lines are perpendicular to each other, then the product of slopes is equals to minus 1. If the product of slopes is equal to minus 1, then the two straight lines are perpendicular to each other. Right? So very, very important thing is, for this case too, there is an exception case. For this case too, there is an exception case. So that is also very, very important. That case is here. The two straight lines are perpendicular. Come again, what is the case 2? If the two straight lines are perpendicular, then the product of slopes is equals to minus 1. For this case, there is an exception case. Let us see what is that. See, this is x-axis and this is y-axis. Right? Is x-axis a straight line? Yes, why not? Why not? X-axis is a straight line. Is y-axis a straight line? Yes, why not? Y-axis is also a straight line. And what is the angle between these two straight lines? 90 degrees. That means the x-axis and y-axis are always perpendicular to each other. Right? We discussed about the slopes of x-axis and y-axis right now, just now. So m1 is equals to what? Slope of x-axis. I said m1 is equals to 0. What is m1? Slope of x-axis. So slope of x-axis is 0, and m2. The second line is y-axis now. What is slope of y-axis? Not defined. Infinity. Infinity. But what is the value of m1 into m2? m1 into m2 is 0 into infinity. Is it equal to minus 1? Is it equal to minus 1? No. No. 0 into infinity is an indeterminate form. That should not be minus 1. But these two lines are perpendicular now. Just now I said that if the two lines are perpendicular, then product of slopes is equal to minus 1. But here m1 into m2 equals to not minus 1. So that is exception case. This happens only in the case of coordinate axis. Only in the case of coordinate axis. So in all the remaining cases, it holds. In the case of coordinate axis, this condition does not hold. That's why that is exceptional case. Okay. Okay. So right. So in the next class, we will discuss about the different forms of straight lines. So do you know how many different forms of straight lines we have? We have 15 different forms of straight lines. 15 different forms of straight lines we have. So in the next class, we will discuss about the different forms of straight lines. Okay. So up to now, till now,